Hello, this video is on sinusoidal models, as shown here in the syllabus. A mathematical model is a simplified description of a real-world system using mathematical concepts. The process of developing a model is called modeling. A sinusoidal model is a function involving either sine or cosine. Sinusoidal models arise in situations where a quantity varies periodically with time, meaning that it repeats itself at regular time intervals. The general form of a sinusoidal model is either a sine bx plus d, where a, b, d are constants. Note that the y-intercept is the point 0, d, and the y-intercept lies on the principal axis. Or a cos bx plus d, where the y-intercept is the point 0, a plus d, and the y-intercept is at a maximum or minimum point. The graph of a sinusoidal model will oscillate about the principal axis. For example, the height of a Ferris wheel pod can be modelled by the periodic function shown. The equation of the principal axis is y equals 112, reflecting that the axis of the Ferris wheel is 112 feet above the ground. The period of the function is 10 minutes, reflecting the fact that a pod takes 10 minutes to complete one full rotation. And the amplitude is 100, reflecting the fact that the radius of the Ferris wheel is 100 feet long. The equation of the principal axis can also be found by adding together the maximum and minimum values of the function and dividing by 2. Remember that the principal axis is the horizontal line located exactly in the middle of the range of the function. And the amplitude can be found by subtracting the maximum and minimum values of the function and dividing by 2. And note that the amplitude is the distance from the principal axis to a maximum or minimum point. The period is the horizontal distance between consecutive maximum or minimum points. In this question, we're asked to find the depth of water in the harbour at 3 p.m. In order to do this, we first need to find the values of the constants a, b, and d. To find d, we need to calculate the equation of the principal axis. Adding together the maximum and minimum values of the function and dividing by 2 gives y is equal to 4. Therefore, d is equal to 4. To find a, we need to calculate the amplitude. Subtracting the maximum and minimum values and dividing by 2 gives an amplitude of 1. Therefore, a is equal to 1. To find the value of b, we need to use the fact that the period is 12 hours. Equating this to the formula for the period, 360 divided by b, and rearranging gives b is equal to 30. Alternatively, we can solve the equation on the calculator. From the main menu, select Equation and press F3, Solver, and then type the equation. Pressing the fraction button, typing in 360 for the numerator, pressing the down cursor and pressing the X variable button for the denominator, pressing the right cursor again, pressing Shift to access equals, and then entering 12. Press Execute to enter the equation. Note that the value next to x is not the solution as we haven't pressed Solve yet. Press F6 to solve the equation, writing down the value of x, which represents b in our case. So as before, b is equal to 30. Having calculated a, b and d, next state the model by substituting in the values of a, b and d. To find the depth at 3 p.m, identify the value of t. 3 p.m. is 1500 hours, which is 15 hours after midnight. Substitute in the value of t, replacing t with 15 and performing the calculation gives h is equal to 5. So at 3 p.m. the depth of the water is 5 meters. In part A of this question, we're asked to sketch the graph of d against t for the periodic function given. To draw the graph on the calculator, from the main menu, select Graph. Type the function into y1. So that's 5, pressing the cos button, opening a bracket, typing in 30, pressing the x variable button, closing the bracket and adding on 20. Press execute to enter the function. Shift F3, view window, to set an appropriate window. The domain for t is 0 to 24, so set in an x min of 0, an x max of 24. And I'm going to set a scale of 3. For y, I'm going to set y min equal to 0, y max equal to 30, and a scale of 5. Press exit and then F6 to draw the graph of the function. Make a neat sketch. Label the axes and show the domain. Identify the y-intercept. You can do this by replacing t with 0 and performing the calculation given a value of 25. Alternatively, you can use the calculator. Press F5, G-solve, then F4, y-intercept. Write down the value of y, which represents d. As before, the value of d is equal to 25. In part B, to find the average daytime temperature during May, identify the value of t. And since May is 4 months after January, the value of t is equal to 4. Substituting this into the function and performing the calculation gives a value of 17.5. Alternatively, you can use the calculator. On the calculator, this is a y calculation. Press F5, G-solve, F6 to get to the second page of tabs, and F1 for a y calculation. Enter the value of x, which is 4, and press execute. Write down the value of y, which is 17.5 as before. So the average daytime temperature during May is 17.5 degrees C. In part C, to find the minimum average daytime temperature and the month in which it occurs, again use the calculator. We need to find the minimum point. Press F5, G-solve, F3 for a minimum. Write down the values of y and x, which represent d and t. T equaling 6 is 6 months after January, which is July. So the minimum average daytime temperature is 15 degrees and it occurs during July.